Hello students, welcome to EPG Pathshala. I am Gaurav Gupta from Sharda University. Today we are going to discuss about a module Project Planning Critical Path Method CPM under paper Operations Management. Objectives. This chapter would help students to understand importance of project planning, rules of network construction, importance of CPM in project planning, and last, application of CPM in estimating trade-off between time and cost of project. Building of a house requires carrying out numerous activities sequentially as well as simultaneously. It is necessary to identify type of activities and resources required to carry out such activities. Some of such activities might be creating foundation, construction, woodwork, electric work, interior design, etc. Each activity can be further broken down into number of activities. Thus, project in this example, construction of house involves combination of numbers of activities arranged in such a sequence so as to achieve completion of project in significant period of time. Definition of project involves following important aspects. Identification of activities. Which activities need to be performed for completion of project? Sequence of activities. Which activities are to be performed in what sequence, and can some of them be performed simultaneously or can some of them be combined? Resources required. Each activity requires certain resources in terms of man, machine, material, time, and effort. How much individuals are required to perform a particular activity? Can they be used for performance of other activities? How much time does each activity take? What is the cost required to perform each activity? Critical activities. Which are the most important activities and what is the time required to complete those activities? Can these activities be delayed, and if yes, what would be the effect on project completion time? What are non-critical activities or activities which can be delayed without delaying the project? Thus, a project involves number of aspects and its successful completion requires a scientific and systematic approach. PERT and CPM are two of the such approaches which answers above mentioned questions. These two methods are network-oriented techniques used primarily to determine project completion time. This chapter discusses CPM in detail with illustrations. CPM is used to find out critical and non-critical activities. The identification of such activities helps a manager to evaluate which activity can be delayed and which cannot, with an effect on project completion time. Also, chapter discusses time cost model of project which provides the effect of change in time of activity on total cost of completion of project. Project management importance. Project management primarily involves following three managerial functions. 1. Planning. Planning involves identification and breaking down of activities into viable and feasible tasks that must be performed for completion of project. It also involves determination and allocation of resources to each activity. It requires estimation of numbers of man hours, amount of material required, costs that would be incurred, etc. for each activity. Number 2. Scheduling. Scheduling involves arranging activities in a logical sequence that would help in converting allocated resources to desired outputs in most productive manner. It is important to note that identified activities can be arranged in different ways to obtain certain outputs, but it is important to find out the most productive way of arranging activities. Such approach would also require identification of critical activities and estimation of available idle time for which activities can be delayed. Control function involves review of project progress. This function determines whether each activity is performed in estimated duration, uses allocated resources, or is deviating from planned schedule. This function allows controlling any difference between planned and actual schedule. The reason for such a difference are analyzed and remedial measures adopted. PERT and CPM methods of project management helps management to achieve these functions effectively, as these methods identifies and estimates time for performance of activities, arranges them in most efficient sequence, and provide data regarding any deviation from planned scheduled. Application of these methods require understanding of construction of network diagrams representing arrangement of project activities. This has been discussed in following section. Network construction, some definitions. Network is a web of identified activities showing their arrangements or sequence in diagrammatic fashion. Construction of network diagram requires understanding of following terms. Activity. An activity is a task that requires certain resource such as time, money, and labor for its completion. In a network diagram, it is represented by an arrow. An activity occurs over a period of time. Event. An event indicates start or finish of an activity. It is represented by a circle called as node. An event does not consume any resource and it occurs at a point in time. If in a network diagram an activity is represented by arrow and an event by node, then such a diagram is called as activity on arrow, AOA, network diagram. Whereas if in a network diagram an activity is represented by a node and an event by a arrow, then such a diagram is called as activity on node, AON, network diagram. Predecessor. An activity which has to be completed before the start of another activity is called predecessor to start of new activity. Successor. An activity which starts after or succeeds the finish of another activity is called successor or succeeding activity. Concurrent activity. An activity which is performed simultaneously with some other activity is called concurrent or parallel activities. These activities are illustrated in figure. This is an activity on arrow network diagram. A is preceding activity to C, which is preceding to E. Similarly, B is preceding to D, which is preceding to F. Activities can also be explained in successor terms. E activity will start after finish to C, that is, succeeds C, which succeeds A. Similarly, F succeeds D, which succeeds B. Events are depicted to circles called as nodes. They indicate the start and finish of an activity. It is important to note that A and B start from some node at same time, making them concurrent or parallel activities. Critical path method CPM. CPM is a deterministic approach of network technique where duration of each activity involved in completion of project is known with certainty. Certain activity times would be known in cases of projects which are repetitive or are not new for an organization. For example, an IT firm specializing in creating software for different banks would apply CPM for a new banking project. As company has already created software for other banks, so creating software for new bank would involve similar tasks for which completion time is known with high certainty. The purpose of CPM technique is to find scheduled project completion time. Second, schedule start and finish times for each activity. Next, identification of most important or critical activities which should be completed within scheduled time and without delaying the project. Identification of non-critical activities which can be delayed by specific time without delaying the completion of project from its scheduled time. To achieve objective of CPM, certain terms have to be understood. Earliest start time EST of an activity indicates the time at which an activity can start as soon as possible. Earliest finish time EFT of an activity indicates the earliest possible time at which an activity can be completed. It is the sum of EST and duration of that activity. Calculation of EST is governed by forward path rule. This rule states that for calculation EST, we should move forward from first event to the last event in a network diagram. As an activity cannot start until all preceding activities have been completed, so EST of an activity is equal to the latest EFT of immediate preceding activity. Latest finish time LFT of an activity indicates finish of an activity as late as possible without having an effect on scheduled finish or entire project. Latest start time of an activity indicates start of an activity as late as possible without having an effect on scheduled finish of entire project. LST is the difference of LFT and duration of particular activity. Calculation of LFT is governed by backward path rule. This rule states that for calculating LFT, we should move backwards from last event to the first event in network diagram. As purpose is to finish an activity as early as possible, so LFT for an activity is the smallest of latest start time of immediate succeeding activities. Slack is determined after finding out all earliest and latest times by moving forward and backward in the network diagram. Slack indicates idle time of an activity with which it can be delayed without increasing the project completion time. It can be computed as LFT minus EFT or LST minus EST. Following notation would be used to represent discussed times. event, EST of succeeding activity, LFT of preceding activity. A project manager has identified following activities, their logical sequence and their duration times in days for completion of a project. How CPM technique can help the manager to plan, schedule and complete the project. Activity A, activity time in days 9, B8, C5, D8, E7, F5, G5. Predecessor to C is A, to D is A, E, B, F, C, G, D and E. Step 1. Construct network diagram. Network diagram is constructed according to the logical sequence as shown in following figure. From E2 it's going to E4, it's going to E6, and from E1 it's going to E3 to E5. Calculation of scheduled time. Activity A. Activity time in days 9, EST 0, EFT 9, LFT 9, LST, LFT minus T equal to 0, slack LST minus EST 0, critical path yes. Activity B. Activity time 8 days, EST 0, EFT 8, LFT 10, LST 0, slack 2, critical path no. Activity C. Activity time 5 days, EST 9, EFT 14, LFT 17, LST 12, slack 3, critical path no. Activity C. Activity time 5, EST 9, EFT 14, LFT 17, LST 12, slack 3, critical path no. Activity time for D 8 days, EST 9, EFT 17, LFT 17, LST 9, slack 0, critical path yes. For E, activity time 7, EST 8, EFT 15, LFT 17, LST 18, slack 2, critical path no. Activity F, activity time 5 days, EST 14, EFT 19, LFT 22, LST 17, slack time 3, critical path no. Activity G, activity time 5 days, EST 17, EFT 22, LFT 22, LST, LFT minus T that is 17, slack LST minus EST that is 0, critical path yes. EST is calculated by moving forward in a network diagram. Activity A starts at E1 and it can start at the earliest, that is at 0 time. Activity C starts after finish of A, which happens after 9 days. So its EST is 9 days. Now what should EST for of G? Activity G will start only after finish of activities A, B, D and E indicated by event ES. E5. Now E5 can be reached by moving along paths A to D and B to E. Total completion time of path A to D would be 9 plus 8 equal to 17 days, whereas of path B to E would be 8 plus 7 equal to 15 days, as G would not start till all preceding activities are finished, so its start time would be 17 days. LFT is calculated by moving backwards from last event in the network diagram. E6 indicates finish of all paths. Now E6 can be reached by moving along A to C to F, A to D to G and B to E to G. Total time for each of the paths would be 19 days, 22 days and 20 days respectively. As project cannot be finished till all activities are completed, so LFT of E6 would be 22 days. Moving backward, C finishes at E4. its LFT would be 22 minus 5 equal to 17 days, and so on. Interestingly, finish of E2 can be achieved by moving backwards from F to C or from G to D. For F2C, LFT would be 22 minus 5 equal to 12 days, and for G to D, LFT would be 22 minus 5 minus 8 equal to 9 days. As an activity should be finished as early as possible, so by moving backwards, minimum LFT should be considered. So finish of E2 or LFT of activity A would be 9 days. All other times will be calculated and shown in table. Step 3, calculating of slack. Zero slack of an activity would indicate that such an activity cannot be delayed or it has to be completed within scheduled time. Such activities are most important activities in a project and constitute critical path. In this case, A to D to G constitute critical path which would take 22 days. This would also be the project completion time, that is, project comprising of above mentioned activities would take minimum of 22 days. Activities with some slack are called as non-critical activities. For instance, activity B with slack of 2 days implies that even if start of this activity is delayed by 2 days, then also project would be completed in 22 days. Final network diagram is shown as. Crashing. The major application of CPM is to estimate the impact on total cost associated with project if project completion time is reduced. The knowledge of scheduled start and finish time of each activity, slack of each activity, and identification of critical and non-critical activities obtained from application of CPM is used in estimating cost of project with change in project completion time. In network techniques of PERT and CPM, the resource used with each activity is the duration of the activity, but performance of each activity also uses other resources such as labor, materials, etc., which incur cost. Crashing method used this information of cost associated with performance of each activity to achieve the objective of estimating project time. It is important to understand that with reduction in activity time, more resources would be required for its completion, thus increasing its cost. That is why there would always be a trade-off between time and cost. So, question that a project manager faces: which activity to be crashed, that is duration time of which activity should be reduced so that the project time gets reduced. What is the increase in cost of project completion with reduction in time period of identified activities? For how much time period an activity can be crashed? Crashing should be done indefinitely. A stage will come when further crashing of activities will not reduce total project completion time, but it would increase cost significantly. As illustration discussed below would show that with decrease in time of an activity, it increased direct cost such as cost of machinery, labor, etc., and reduces indirect costs such as cost of lighting, rent, security, etc. At first, total cost would reduce with reduction in project time because proportion of increase in direct cost is less than decrease in indirect cost. But after certain reductions in time period, proportion of increase in direct cost would outweigh reduction in indirect cost, thus increasing total cost. This is an indication that further crashing would not result in optimum results. The objective of crashing gets defeated. So, a project manager should stop crashing when all the paths in network diagram becomes critical or total cost start increasing. Following are certain terms that must be understood in application of crashing. Normal time. It is expected time of completion of activity. Crash time. It is reduced time of completion of activity. Normal cost is the cost of performance of an activity when performed under normal conditions. Crash cost is the cost of performance of an activity when performed under reduced time. Following are the steps to be used in crashing of a project. Step 1. Draw network diagram. Step 2. Find cost slope of each activity. Cost slope is the increase in direct cost of an activity when its duration is reduced by 1 day. Cost slope equal to change in cost oblique change in time. Step 3. Find critical path. As discussed, critical path is found by calculating EST, EFT, LST and LFT. By definition, critical path is the longest path in the network diagram. In example shown under, critical path is estimated by finding the longest path in diagram. Step 4. In the critical path, find an activity which least cost slope because aim is to reduce project time with least increase in cost. Step 5. Estimate the time for which selected activity can be crashed. For this, a general rule that is followed is that activity should be crashed for so much time that it does not result in change of critical path. Step 6. Keep on repeating the process till further reduction in time period leads to increase in cost or when all paths in network diagram have become critical. Example, for the following project, estimate total project cost under normal times and crash times. Indirect cost is 100 per day. Activity A, predecessor nil, time 8 days, cost 100 rupees, crash time 6 days, cost 200 rupees, cost slope 50. Activity B, predecessor nothing, time 4 days, cost 150, crash time 2 days, cost 350, cost slope 100. Likewise, activity C, predecessor A, time 2 days, cost 50, time 1 day, cost 90, the cost slope becomes 40. Likewise for activity D, the predecessor is A, time 10, cost 100, crash time 5, cost 400, cost slope 60. Activity E, predecessor B, time 5 days, cost 100, time crash 1 day, cost 200, cost slope becomes 25. Activity F, predecessor C and E, time 3 days, cost 80 and crash time 1 day, cost 100, then cost slope is 10. Steps in solving for crashing example. Draw network diagram. Step 2. Find cost slope of each activity. For instance, cost slope of A equal to 200 minus 100 upon 8 minus 6 equal to 50. Cost slope of B is 350 minus 150 upon 4 minus 2 equal to 100 and so on. Find critical path from start to finish, all paths in networking diagram. B to E to F 12 days, A to C to F 13 days, A to D 18 days. Critical path by calculating the longest path would be A to D taking 18 days. The project completion time under normal conditions would be 18 days. Step 4. In critical path, that is A to D, least cost slope is of activity A, that is, if duration of A is reduced by 1 day, then increase in direct cost would be 50 per day. Step 5. Estimate the time for which selected activity can be crashed. Activity A can be crashed by 2 days without making any other path critical. So project time would be 18 minus 2 equal to 16 days. Initial total cost, that is when project is completed in 18 days, equal to direct cost plus indirect cost equal to 580 plus 18 into 100 equal to 580 plus 1800 equal to rupees 2380. When project is completed in 16 days, increased in direct cost equal to 2 into 50 equal to rupees 100. Indirect cost 16 into 100 equal to 1600. So total cost 580 plus 100 plus 1600 equal to rupees 2280. Path A to D is critical when longest time duration is 16 days. As A is now being done in 6 days, so it cannot be crashed further. D can be crashed by 5 days, but if it is crashed by 5 days, then path A to D would become non-critical, which violates the rule, that is, crashing should be done in such a way that existing critical path should not become non-critical. So D should be crashed by 3 days. In such a way, both A to D and A to C to F would become critical, taking 13 days for project completion. By crashing D by 3 days, project completion time equal to 16 minus 3 equal to 13 days. Increase in direct cost equal to 3 into 60 equal to rupees 180. Indirect cost equal to 13 into 100 equal to rupees 1300. Total cost 680 plus 180 plus 1300 equal to rupees 2160. Now there are two critical paths, A to D and A to C to F. If A to D, only D can crashed further by 2 days with increase in cost of rupees 60 per day. In path A to C to F, activity F with least cost slope can be crashed by 2 days, but if both activities are crashed by 2 days, then it again violates the rule of critical path, that is, it would make other path B to E to F as critical, which is not acceptable, so crash both D and F by 1 day. Project duration would be 13 minus 1 equal to 12 days. Increase in direct cost 1 into 60 plus 1 into 10 equal to rupees 70. Indirect cost 12 into 100 1200. Total cost 780 plus 70 plus 1200 equal to rupees 2050. Now all three paths are critical with 12 days as project duration. From path A to D, activity D can be crashed further. So students, let us summarize what we have learnt in this module. Project is a combination of activities arranged in a sequence to achieve objective of completion of project. Planning of project becomes increasingly difficult if it involves numerous activities. Thus, need of managing project arises when involves arranging activities in a sequence, which would help in completing the project most productively. Management of project can be done by using two time oriented network techniques, namely PERT and CPM. These techniques are similar to each other in fulfilling objectives of finding project completion time and identifying critical and non-critical activities. They differentiate from each other in a manner that CPM is a deterministic approach used for projects which have been carried out earlier also, whereas PERT is a probabilistic technique used for finding out probability of completion of project within a scheduled time of those projects which are new and project manager has little experience for their conduct. Crashing is the time cost trade-off technique used to find minimum possible time in which project can be completed with minimum impact on cost. Thank you.